students, a very good morning to all. I am Dr. Shagupta Khan from the School of Electrical, Electronics and Communication Engineering. Today we will discuss about the excitation system in power system network. So this topic comes under the subject facts and HVDC. Need of excitation system. So it is used to meet the specified response criteria. Then it provides the limiting and protective functions as required to prevent damage to itself, the generator and the other equipment related with that. Then it meet specified requirement for operating flexibility. It also meets the desired reliability and availability by incorporating the necessary level of redundancy and internal fault detection and isolation capability. So for these purpose we need the excitation system in the power system networks. So this is the functional block diagram of a synchronous generator excitation control system. So here what the actually blocks we are using, so that is exciter, then we have the regulator, and then terminal voltage transducer and load compensator, and the power system stabilizer, and limiters and protective circuits. So now we will discuss about each and every component of the excitation system one by one. Now the exciter, first exciter, as you know, in the synchronous machine, on the stator side, armature are connected on the stator. So the stator side, the AC supply is given, and on the rotor, field winding are connected. On the rotor, DC supply is given. So for that synchronous machine operation, so exciter provide DC power to the synchronous machine field winding and constitute the power stage of the excitation system. Now, what is the role of the regulator in the excitation system? It processes and amplifies input control signal to a level and form appropriate for control of the exciter. So whatever the level is controlled by the exciter, so it gives that proper level of that input and process the amplifies input control signal to that particular level. This includes both regulating and excitation system stabilizing functions. Now the terminal voltage transducer and the load compensator. So it has like transducer and compensator. So senses transducer, so it senses generator terminal voltage. It will sense the generator terminal voltage, then rectifies and filter it to the DC quantity and compare it with the reference which represent the desired terminal voltage. So it will actually change to the DC and it will compare with the desired terminal, it will compare with the reference value. In addition, the load or line drop or reactive drop compensation may be provided if it is desired to hold constant voltage at some point electrically remote from the generator terminal. For example, like partway through step-up transformer. So it is used for that purpose. Now the function of the power system is stabilizer in excitation system. It provides an additional input signal to the regulator to damp power system oscillations. So it is providing the additional input signal so that it can damp out the oscillations. Then some commonly used input signals are rotor speed deviation, then accelerating power and the frequency deviation. So the stabilizer is basically is using to regulate the to damp out the oscillation in the system. Then limiters and protective circuits. So these include a wide array of control and protective functions which ensure that the capability limits of the exciter and synchronous generator are not exceeded, so that it can operate in a limit. So some of the commonly used functions are the field current, then the limiter, maximum excitation limiter, then terminal voltage limiter, volt per hertz regulators and protection, and under excitation limiters are under this. These are the normally distinct circuits and their output signals may be applied to the excitation system at various locations as a summing input or a gated input. So this is so the limiters. It's also a role which is setting the output or the up to within a limit. Types of the excitation system. So there are three types of the excitation system: DC excitation, AC excitation system, and the static excitation system in case of the synchronous machine excitation system. DC excitation system. So as in a synchronous machine, on the rotor where the field winding are placed, so there a DC supply is given. So it can be given by using the DC generators. It can be self-excited or self-excited or separately excited. So when separately excited, the exciter field is supplied by a pilot exciter comprising a permanent magnet generator. So in early days, like in 1920 to 1960, DC excitation system was used, but in mid of the 1960, it is replaced by the AC excitation system. So AC excitation system were in demand that time. So now we are having some system which are having the DC excitation system, but in some of the excitation system are replaced by the AC excitation system. Now see, this is the DC excitation system with amplitude voltage regulator. Now see, this is the main generator or synchronous machine where the field winding is on the rotor side and the armature winding on the stator side. So CTPT are also connected for that protection. Now this terminal voltage of the synchronous generator is basically controlled, and here the excitation is provided, the field winding it is providing through this DC generator. So see here, this DC generator through the slip ring it is provided the DC supply to the field winding of the main generator or the synchronous machine. So this amplitude is also connected, amplitude voltage regulator is connected, which is used to regulate the voltage, and slip ring are showing here through which the DC supply is given to the field winding of the synchronous machine or the main generator. Under AC excitation system, we have the stationary rectifier system. So here the DC output is fed to the field winding of the main generator through slip ring. So DC is providing to the field winding of the synchronous machine or the main generator, and this is actually the DC is generated through the known controlled rectifier, or the regulator controls the field of the excitation, which is control the exciter output voltage. So this is the DC is generated through the known control rectifier where the diodes are used. So field control turbulent rectifier excitation system. Here the main generator, field winding and armature winding are showing here. So this on the field winding of the synchronous machine, this we have to provide the DC supply. So here the rectifier, by using DC regulators are used to actually regulate the voltage level of this controller of that rectifier. Now the field winding after the conversion from AC to DC, so here the DC is supplying to the field winding. Alternator supplied controlled rectifier excitation system. So here the stationary controlled rectifiers are used to control the DC output voltage, which is actually given to the field winding of the main synchronous machine and through slip ring. So there is a control. By using this control rectifier we can have, and this is the AC excitation system, and this is the main generator, one main generator on which the field winding we are providing the DC supply through this excitation system. So there's this DC voltage, whatever which is given to the field winding, it is controlled by this controlled rectifier system, that is stationary. Now the rotating rectifier system. So here also from AC to DC, AC excitation system we are using. First it will convert from AC to DC, and then it is given to the field winding of the main generator. So here it is rotating rectifier system used in the AC excitation system. So with rotating rectifier, the need for slip rings and brushes is eliminated as it is rotating, and the DC output is directly fed to the main generator field. So here, so slip rings are not there. The armature of the AC exciter and the diode rectifier rotates with the main generator field. A small AC pilot exciter with the permanent magnet rotor rotates with the excited armature and the diode rectifier. The rectified output of the pilot exciter stator energizes the stationary field of the AC exciter. The voltage regulator controls the AC exciter system, which in turn controls the field of the main generator. So such a system is referred to as a brushless excitation system, and it was developed to avoid problem with the use of brushes that were perceived to exist when supplying the high field current of the very large generator. So it is used a brushless excitation system, we can say, in case of the rotating rectifier system. So this is showing the brushless excitation system. In this, like, we are having the main generator, field winding, and the armature is showing here, and CT and PT are used for the protection. Then the regulator is there, so the manual control and the auxiliary input is coming there. Then we are having the AC exciter and pilot exciter. So you can see the slip rings are not showing here because it's a brushless excitation system, so slip rings are removed. Then now see the rectifier and the armature of the AC exciter are rotating. So the pilot exciter output, the response of this is exciting the field winding of the exciter, and then the control DC voltage is provided to the field winding of the armature, field winding of the synchronous machine. So this is the brushless excitation system. Static excitation system, where all the parts are static. You can see the main generator, the slipping is showing here, so through which the DC supply is given to the field winding. Now the control rectifier, that is also static. Then exciter transformer is used to convert the voltage level up to the desired value. So this is all the elements is showing the static. This is potential source control rectifier excitation system. So compound source rectifier excitation system, it's also a static excitation system. Here the power is given to the excitation system by using current and voltage. So here the potential transformer is used, and the current transformer and there is saturable current transformer, both are used, and all are static parts are used in this excitation system for the control of the excitation output of the for the control of the output of the excitation system. Voltage regulators are used. So this is also the static excitation system, where which is called as a compound source, where voltage source and the current source both are involved for the input of the excitation system. Now these are the references which you can follow for this topic. Thank you so much.